Hey everyone! In this video we're on page 47 looking at the last problem, problem D. 2 sine squared x minus 3 sine x plus 1 equals 0. This problem's actually going to be really similar to what we did in problem C. So before I go over this problem, pause the video and try this problem on your own. See if you can do it based on what we learned in problem C. Okay, so let's come back. So now I'll go over problem D. I'm going to just flip over the page because I know I'm going to run out of room if I don't. So D is 2 sine squared x minus 3 sine x plus 1 equals 0. The first thing I'm going to do, like we did in problem C, is change sine into a variable. That way when we solve it, it's going to look a lot easier and more like what we're used to seeing with variables rather than trig functions. So this time I'm just going to call sine y. I'll say that y equals sine x. Okay, now we'll go ahead and rewrite the equation using y instead of sine. So we have 2 sine squared. So now instead of sine, we're going to say y squared minus 3 sine x, and again, instead of sine, we're going to use y, plus 1 equals 0. Okay, so there's our new equation. 2y squared minus 3y plus 1 equals 0. So just like problem C, it's a quadratic equation. That means we need to use the Punnett square again. So let's go ahead and write our Punnett square. Again, in the first box, we're going to write our first term, 2y squared. The second box, the middle, we're going to write our middle term, negative 3y. And in the last box, we'll write our last term, plus 1. Okay, so now we need to figure out what numbers multiply 2y squared and what two numbers multiply to get 1. Notice this is really similar to what we did in problem C. We already know that to get 2y squared, we can use 2y and y. So 2y and y, because 2y times y gives us 2y squared. To get 1, we can just use 1 and 1. Because 1 times 1 gives us 1. So again, let's see what we get. We get 1 times y, that gives us y, or 1y, the same thing. 2y times 1 gives us 2y, because 1 times 2y equals 2y. Okay, now we need to check if the middle term, if we get the middle term by adding these two numbers. So let's see, 2y plus y, does that give us negative 3y? Notice it does not. In this case, 2y plus y gives us positive 3y. So that means we need to do something with the signs. We need to change something. So if we had negative 2y and negative y, then negative y plus negative 2y would be negative 3y. So we need to make them both negative. So I'll just go ahead and change some of our signs. So we can change the sign on 1 to be negative, because then negative 1 times y gives us negative y. And now we want this one to be negative, so we can turn this negative, because negative 1 times 2y gives us negative 2y. And negative 2y plus negative y gives us negative 3y, like what we want. Perfect. So that's our two answers for our Punnett square. The outside equations. So y minus 1 and 2y minus 1. Now we need to go ahead and solve them. So I'll go ahead and write them down here. I'll start with the first one. So 2y minus 1. 2y minus 1 equals 0 again. and then y minus 1 equals 0. Okay, so those are our two equations from here. Now let's go ahead and solve the first one. To solve that one, we need to add 1 on both sides to get y by itself. So go ahead and add 1. Negative 1 plus 1 is 0. It just cancels out. We can bring down our 2y. Bring down our equal sign. And 0 plus 1 is just 1. So 2y equals 1. Now, to get y by itself, we can divide by 2. What we do to one side of the equation, we have to do to the other. 2 over 1 is just 1, so we get a single y. That tells us that y equals 1/2. Okay, now let's go ahead and solve the second one. For that one, we want to get y by itself, so we need to add 1 to both sides of the equation. So add 1. Negative 1 plus 1 is 0. It cancels out like what we wanted. Bring down our y. And we're left with y equals, y equals 0 plus 1, which is just 1. So y equals 1. Okay, so we got our two answers for y. Y equals 1/2 and y equals 1. So again, it kind of feels like we're done, but we need to remember that y is actually sine. So now we're going to go ahead and replace our y with sine. So what we actually have is sine x equals 1/2, and sine x equals 1. Because again, I just replaced our y's with our sine, because we replaced them in the beginning. Now to finish the problem, we need to put sine back in. Okay, now it's just like the problems we've been seeing. What angle makes sine 1/2, and what angle makes sine equal to 1? So let's start with 1/2. So in our unit circle, if we're looking for sine to be 1/2, we need to remember that sine is our y-coordinate. Our y-coordinate, or sine, is positive in the upper two quadrants above the x-axis. So let's look for our y-coordinate being 1/2. Looks like right here. At 30 degrees, sine is 1/2. So that tells us that x can equal 1/2. 30 degrees. Or pi over 6, because it's the same thing. Pi over 6 is the same as 30 degrees. Okay. Now, sine is also going to be 1/2 in quadrant 2 on the unit circle. And that's going to be right here at 150 degrees, or 5 pi over 6 radians. So x, our angle, can be 150 degrees, which is the same thing as 5 pi over 6 radians. Okay, so those are two of our angles for 1/2, because at 30 degrees, or pi over 6 radians, and at 150 degrees, or 5 pi over 6 radians, sine equals 1/2. Now we need to figure out where sine equals 1. So go into our unit circle. Sine equals positive 1 above our x-axis. It looks like right here at 90 degrees, or pi over 2 radians. So x also equals 90 degrees, or pi over 2 radians. Because at 90 degrees, or pi over 2 radians, sine equals 1. Okay. So that means we got 3 answers for problem D. Because, again, at 30 degrees, or pi over 6 radians, and at 150 degrees, or 5 pi over 6 radians, sine equals 1/2. And at 90 degrees, or pi over 2 radians, sine equals 1. So that's problem D. Thanks for watching, guys.